Hey everyone, welcome back to The Explainer. Today we're diving headfirst into something kind of technical, but honestly, absolutely crucial. We're decoding the official SASB standards for midstream operational safety and breaking them down into clear, digestible metrics. So, whether you're a compliance officer, an ESG analyst, or just someone who's fascinated by how massive industrial risks are actually measured and managed, you are in the exact right place. We're going to look at the precise numbers and rules that define safety in the midstream oil and gas sector.
Okay, let's dive into this. Here is our roadmap to demystify these reporting thresholds. We'll hit the stakes of midstream safety, reporting pipeline incidents, defining significant incidents, pipeline inspection metrics, tracking rail releases, and finally, building a safety culture. Let's get started.
Section 1. The stakes of midstream safety. Vast networks, immense stakes.
Think about it. The midstream industry runs this incredibly vast, sprawling web of pipelines, rail cars, and storage facilities. They're transporting hazardous materials day in and day out. In this kind of environment, a single failure doesn't just mean a delay. It can literally mean an absolute catastrophe. Now, to measure how companies handle these immense stakes, we rely on the official SASB standards. These are now under the stewardship of the International Sustainability Standards Board, or ISSB, within the IFRS Foundation. And the ISSB actually requires entities to refer to these specific standards to identify their sustainability-related risks. So what we're looking at today isn't just some casual best practice, it's the global reporting benchmark.
Before we hit the actual numbers, we have to understand the why behind these metrics. Any incident that causes an unintended hydrocarbon release can have severe and sometimes irreversible impacts on the environment, employees, and local communities. For a midstream entity, these incidents create massive contingent liabilities. We're talking about astronomical costs for remediation, legal damages, regulatory fines, and ultimately the potential loss of the company's social license to operate. The human and financial consequences are exactly why tracking this with precision is so critical.
Moving right along to Section 2, reporting pipeline incidents. Hazardous liquids versus gas transmission.
And this brilliantly illustrates why you cannot measure liquids and gas the same way. They just don't behave the same way. Hazardous liquid incidents are triggered by very objective events, unintended explosions, fires, a death, an injury needing hospitalization, or exceeding jurisdictionally defined property damage thresholds. Gas transmission incidents, on the other hand, share those human and financial triggers, but they also include the emergency shutdown of a liquefied natural gas, or LNG, facility. Plus, gas reporting actually includes an element of subjective operator judgment. An event must be reported if the operator deems it significant, even if it doesn't hit the specific numerical criteria.
But when we do get to the numbers for hazardous liquids, they are incredibly precise. 19 liters. That's it. A release of just 19 liters or more of a hazardous liquid in transit is an automatically reportable incident. Now, there is a very specific exception to this rule. A release of less than 5 barrels, which is roughly 795 liters, is exempt, but only if it results from routine pipeline maintenance, doesn't pollute any water, is confined to company property, and is promptly cleaned up. But otherwise, just 19 liters triggers a report.
Now contrast that liquid threshold with the gas threshold. 85,000 cubic meters, or actually, if you prefer imperial units, 3 million cubic feet. Under the SASB standard, an unintentional estimated gas loss of this massive volume from a pipeline or LNG facility automatically triggers a reportable incident. It is a stark contrast to that tiny 19-liter liquid rule, and it's driven entirely by the physical differences between an escaping gas and a pooling liquid.
All right, Section 3, defining significant incidents. When exactly does an incident become a major event?
So, once a company reports its total incidents, SASB requires them to track a crucial secondary metric. What percentage of those total incidents actually escalated into something significant? The standard elevates an incident based on severe human or financial tolls. If an incident results in a fatality or an injury requiring inpatient hospitalization, it's significant. If the total costs, and that includes cleanup, the value of lost product, and property damage, exceed the jurisdictionally defined property damage thresholds in the local currency, it's significant. Oh, and any liquid release that causes an unintentional fire or explosion, that automatically hits this Tier 2.
So the crucial point is how volume triggers significance. For highly volatile liquids, a release of just 5 barrels is considered significant. For other hazardous liquids, the threshold is 50 barrels. By tracking the percentage of incidents that breach these specific thresholds, analysts can see not just how often a company has a spill, but how often those spills really start spiraling out of control.
Section 4. Pipeline Inspection Metrics, Measuring Preventive Action.
Okay, we've talked a lot about what happens when things go wrong. But how does SASB actually measure a company's preventative actions? Well, the key metric here is the percentage of their natural gas and hazardous liquid pipelines that were actually inspected during the reporting period. And the math required by this standard is refreshingly straightforward. Step 1, you calculate the length of the pipeline inspected. Step 2, you divide that by the total length of the pipeline system. Simple, right? But here's the catch. You cannot just lump all your assets together. This calculation has to be reported separately for natural gas pipelines and for hazardous liquid pipelines. That gives us clear visibility into the integrity of each distinct system. But what actually counts as an inspection? Well, compliance here requires a really fascinating mix of boots-on-the-ground physical checks and high-tech diagnostics. Accepted activities include things like physical patrolling and leakage surveys, targeted checks of navigable water crossings, or assessing areas that were recently hit by extreme weather. It also goes all the way up to complex inline integrity assessments, pressure testing, and deep dive checks for internal and external corrosion. A company also has to disclose the specific technologies they're using to run these critical checks.
Section 5. Tracking rail releases. Accident versus non-accident releases.
So midstream operations aren't just pipelines, right? They include a massive logistical web of rail transportation, moving things like explosives, radioactive materials, flammable liquids, and toxic substances. And when it comes to rail, the reporting splits into 2 very specific categories: accident versus non-accident releases. If you ever read midstream ESG reports, you are inevitably going to come across the acronym NAR. So I'll pose the question directly to you. What exactly is an NAR?
Well, a NAR stands for a non-accident release. SASB defines this as the unintentional release of a hazardous material while in transit, and by the way, that includes loading and unloading while the rail car is in the railroad's possession. That is specifically not caused by a derailment, collision, or other rail-related crash. This metric is huge because it shows us that every day, non-collision rail operations still carry immense reportable risks that absolutely must be managed.
Now, what's really interesting about this slide is the stark contrast between the causes. Accident releases, those are your high-profile disasters, derailments, and collisions that immediately trigger mandatory reporting to jurisdictional agencies. Non-accident releases, on the other hand, are more like your quiet, operational failures. We're talking leaks, splashes, or releases from improperly secured or defective valves, fittings, and tank shells. And importantly, NARs do include the venting of non-atmospheric gases from safety relief devices, but they actively exclude the normal, safe venting of atmospheric gases like nitrogen or carbon dioxide.
Finally, Section 6, the ultimate goal, safety culture, integrating safety across the value chain.
All of these highly technical metrics we just went over, the 19-liter thresholds, the NARs, the pipeline inspection math, they're ultimately just indicators. They serve a much larger purpose, which is to track whether an entity is actually integrating a genuine culture of safety across its entire value chain. SASB requires companies to discuss their safety management systems in detail. And to be considered a true systematic approach, safety cannot just be some top-down mandate. It requires joint management by both the workforce and the leadership. It requires enforcing strict rules, deploying advanced technology, and crucially, coordinating emergency preparedness even amongst business partners, like your third-party contractors and subcontractors. Let's move to and see how this builds across time. This is captured perfectly in a specific directive from the standard. A company must integrate a culture of safety and emergency preparedness throughout its value chain and project life cycles. This means the safety culture doesn't just suddenly start when the oil starts flowing. It has to span the entire life cycle, from the very initial land acquisition and right-of-way easement negotiations, through site surveys, pipeline construction, active operations, and all the way out to eventual decommissioning and removal. Which leaves us with a final, absolutely critical thought. We've mapped out the data points today. We know exactly what triggers an incident report and how to calculate inspection ratios, but is mere compliance with reporting thresholds really enough to prevent the next catastrophic midstream incident? Or do these numbers merely serve as a baseline, revealing that true operational safety requires a much deeper, continuous cultural shift? It is something every investor, analyst, and operator must seriously consider.
Thank you so much for joining me to decode these standards. Keep learning, keep questioning, and I'll catch you in the next explainer.